Hi, Steve. I'm recording this for my friend Steve Lufkin, who was a baseball-playing mathematician, baseball coach, mathematics teacher, college baseball player, and in fact, recently he hit pitches from two Hall of Fame pitchers, Bert Blyleven and Frank Viola. So, as the ultimate combination mathematician baseball player, I've known a lot of baseball players, Steve. I've known a lot of mathematicians in my decades as a teacher and athletic trainer. I've never known anyone to marry the two quite as competently as you have. This book made me think of you. What If by Randall Munroe, because he says, I have been using math to answer weird questions for as long as I can remember. And right up towards the front, I thought of you because he says, relativistic baseball. This is the second question. And the question is, what would happen if you tried to hit a baseball pitched at 90% the speed of light? Since you were a catcher, I know what you're thinking. You're thinking, I would get away from the plate. But wait, that will not be good enough. And wait till I explain why. Here we go. The answer turns out to be a lot of things, and they all happen very quickly, and it does not end well for the batter or the pitcher. I sat down with some physics books, a Nolan Ryan action figure, and a bunch of videotapes of nuclear tests and tried to sort it all out. What follows is my best guess at a nanosecond by nanosecond portrait. The ball would be going so fast that everything else would be practically stationary. Even the molecules in the air would stand still. Air molecules would vibrate back and forth at a few hundred miles per hour, but the ball would be moving through them at 600 million miles per hour. This means that as far as the ball is concerned, those molecules are just hanging there frozen. The ideas of aerodynamics would not apply here. Normally, air would flow around anything moving through it, but the air molecules in front of this ball wouldn't have to be jostled out of the way. The ball would smack into them so hard that the atoms in the air molecules would actually fuse with the atoms in the ball's surface. Each collision would release a burst of gamma rays as scattered particles. Here we go, ready? There's the illustration. He's quite the illustrator. These gamma rays and debris would expand outward in a bubble centered on the pitcher's mound. They would start to tear apart molecules in the air, ripping the electrons from the nuclei and turning the air and the stadium into an expanding bubble of incandescent plasma. The wall of this bubble would approach the batter at about the speed of light, only slightly ahead of the ball itself. The constant fusion at the front of the ball would push back on it, slowing it down as if the ball were a rocket flying tail first while firing its engines. Unfortunately, the ball would be going so fast that even the tremendous force from this ongoing thermonuclear explosion would barely slow it down at all. It would, however, start to eat away the surface, blasting tiny fragments of the ball in all directions. These fragments would be going so fast that when they hit the air molecules, they would trigger 2 or 3 rounds of fusion. After about 70 nanoseconds, the ball would arrive at home plate. The batter wouldn't even have seen the pitcher let go of the ball, since the light carrying that information would arrive at about the same time the ball would. Collisions with the air would have eaten the ball away almost completely, and it would now be a bullet-shaped cloud of expanding plasma, mainly carbon, oxygen, hydrogen, and nitrogen, ramming into the air and triggering more fusion as it went. The shell of X-rays would hit the batter first, and a handful of nanoseconds later, the debris cloud would hit. Oh, here's another illustration. I didn't know plasmized was a word, but there it is. The batter, it does not show the catcher because you, the catcher, are way too smart to stand behind this pitch. When it would reach home plate, the center of the cloud would still be moving at an appreciable fraction of the speed of light. It would hit the ball first, but then the batter, plate, and catcher would all be scooped up and carried backward through the backstop as they disintegrated. The shell of X-rays and superheated plasma would expand outward and upward, swallowing the backstop, both teams, the stands, and the surrounding neighborhood, all in the first microsecond. Suppose you're watching from a hilltop outside the city. The first thing you would see would be a blinding light far outshining the sun. This would gradually fade over the course of a few seconds, and a growing fireball would rise into a mushroom cloud. Then, with a great roar, the blast wave would arrive, tearing up trees and shredding houses. Everything within roughly a mile of the park would be leveled, and a firestorm would engulf the surrounding city. The baseball diamond, now a sizable crater, would be centered a few hundred feet behind the former location of the backstop. Major League Baseball Rule 6.08b suggests that in this situation, the batter would be considered hit by pitch and would be eligible to advance to first base. There's the illustration of what would have been left of first base. I hope you've enjoyed this. This is the kind of stuff my son values a great deal. And he is headed, obviously, towards the mathematical scientific realm. So I may be running into more of these things along the way. Very few things, though, connect baseball and mathematics quite the way this guy did in this chapter. I hope you enjoyed it. Take care.